Hi everyone, in this video I'm going to speak about my LNA design. Here you can see that the design is fixed and achieved from ADS and achieved from the PCB. Following slides I'm going to speak about the design procedure. I started with idle component, then transmission line, then the PCB design. Since we are designing an LNA, we need to figure out the biasing point so that we can achieve the minimum noise figure. Therefore I swept current versus noise figure minimum. We should sweep current density, but since we have only one transistor, therefore it will be the same. From this plot we can see that minimum noise figure occur at 5 milliampere, and since we don't have specs on VDD, I swept also VDD or VCC, and the minimum noise figure occurred at 8 volt. Also from the datasheet for this transistor, you can see the VCE is also 8 volt. The current is 1 ampere, but since we are going to use this transistor that we swept, therefore I'm going to use 5 milliampere. We should also check VT, but since VT is so large, I didn't sweep it, and I designed based on this VFT. Also from this noise figure, we can see that we can achieve the specs, as our noise figure is 0.8 and this one is 0.6, then we have about 0.2 dB. The next part is topology selection, and from the datasheet also they use this topology. Therefore we are going to use the same topology, and maybe in the future we can tune it. Topology is clear that it is stable, and we check the maximum gain to check if we can achieve the desired gain or not, and since it's more than 12, then most probably we can achieve it. Then we check the noise circle and gain circle to make some compromise between noise and gain to achieve good gain with minimum noise figure. But it seems that from this plot that even in the best case we cannot achieve the noise figure. Therefore we need to tune the circuit more. After tuning, we can see that gain is more than 12. S11 and S22 is less than 8 and 12, which is the desired specs. See that the noise figure is about 0.789 in the worst case, which is less than 0.8, and also noise figure is very close to noise figure minimum. For stability, even it is stable, but we have these which can cause instability in very low frequency. Therefore we need to do something to solve this problem. For this stability problem is to add this resistance so that it can solve the low frequency problem. Also, we don't know after fabrication what will be the S11 and S22. It may be degraded. Therefore, we need to add this input and output matching network so that we can achieve better S11 and S22. And after fabrication, even if it degraded, we can achieve the specs. That we can see the stability problem in low frequency solve it, and noise figure is improved. S11 and S22 has been improved a lot. There is some degradation in gain, but still achieve the specs. Then we need now to lay out to send it for fabrication. We need to choose the width of the transmission line. For 50 ohm transmission line, we need 71.27. With the inductors, we need to enter the quality factor. Therefore, we checked 0.02 package, and we found these quality factors. Designed to generate the layout will be as follows. As you can see, we added some extra transmission line, and we redraw the circuit so that it will be easier for us to generate the layout. For example, we flip these like that, and we added some corners. After layout is as follows. S1 is still good, S21 more than 12. Stable, and noise figure is less than 0.8. Then for tip out, we send this paper file to be fabricated. Fabrication, we solder the component and check the DC stability to make sure it is not unstable. This is as follows. For the noise figure, it's about 1 dB. Sometimes it can increase more because of the interference from outside. Final summary table is as follows.